I'd like to start this series of lectures with kind of a broad look at what science is and what chemistry is and what cannabis science is. And so we'll start with chemistry. That's what I tend to know best. So let's start with just a general definition for the field. Chemistry is the study of matter and its behavior. But really, we're just looking at matter, and matter is everything around us that has mass and volume. So it takes up space and it's has weight to it, right? And so in general, when we're studying things that are matter, we're really looking at observing how it behaves physically and chemically as well. So we're looking at their chemical and physical properties as well as the physical changes it can undergo or the chemical changes it can undergo. So my favorite version of a chemical change is an explosion. So this is a chemical change. Sure, there's also some physical changes happening here too. We'll talk about what each of those might mean. But really at the heart of chemistry, we're kind of like poking things and observing how they're going to react or how they're going to change. It's also a lot of mixing and seeing what happens. So if we're looking at matter and we're going to study matter, and that is everything that that chemistry is. I think it's also important to note that atoms are really the fundamental particles of matter. And I guess I assume that this is something that's already filtered through to you if you've signed up for this class, but this is an introductory chemistry class. So I probably shouldn't assume, but everything around us that is matter, that has that volume, that takes up space, it has mass, is composed of building blocks that are atoms. And atoms are pretty rare just to be out on their own in nature. Some noble gas atoms are, but really they usually combine together and they create kind of like these specific arrangements with geometries that are pretty specific, and those are molecules, and molecules make up us. They also make up plants. They make up lots of things. um, so things like atoms. So here I just have carbon, oxygen, and hydrogen, three very common atoms in organic matter. Um, can combine in a lot of different ways to make completely different things. So we can have carbon and hydrogen combined and make methane, which is a gas that we can harness and burn for energy. Or we can have oxygen and water combined, and that makes water, which is essential for life. And we can have all three of these atoms combined together in lots of different ways. And one of the ones that it could be is glucose, which is another essential part of us being alive. Um, and this is kind of like the Lego blocks, I guess, of life, right? You've got atoms that are our smallest component that we can't divide up anymore. So you can't take an atom and cut it in half or anything like that. So they're kind of our fundamental particle. And then they can combine in lots of different ways to make molecules. Now, molecules can break apart. You can have a chemical reaction that breaks a bond, and then you have two new things. So in chemistry, we're going to study atoms, we're going to study molecules. And in doing that, we're also going to need to take some time to talk about energy. So matter is going to be basically just our atoms and molecules. But as we study its behavior, we're also going to need to consider potential and kinetic energy. So I want to kind of define those really quick. Potential energy is really stored energy. And so, from a chemistry perspective, we really think of this as being the energy that is stored in chemical bonds. From a physics perspective, potential energy is when you're at the top of a roller coaster or a ladder and you aren't moving a lot, but you have the potential to drop and have a lot of motion. When that happens, your potential energy is converted into kinetic energy, which is the energy of motion, essentially. So things moving around. So in chemistry, that potential energy, instead of being up at the top of a roller coaster or a ladder, really it's just the bonds between two atoms. So, and we'll talk about this in more detail, but when atoms come together, they're going to have stored energy between them, and it would be released if you broke it apart. Now, kinetic energy is really, as I said, motion. So it's a lot of different things for a molecule. It's a lot of stretching and vibrating in different ways. It's also rotating around, and it's just like moving through space. So that's vibrational, rotational, and translational motion. That translational is the motion of actually moving around. Let's talk a bit about another thing that chemists love to do, and that is classify things. Similar to biologists or any scientist, we love to categorize and organize. So we've talked about all matter being made up of atoms and, atoms and molecules right here. But we'll classify all matter into a few different categories to help us kind of focus. So first, we're going to separate it into substances and mixtures. And let's focus on substances first. We can think of things that are substances as being pure, like it's just one thing. But that one thing could be just atoms of the same type. We would call this an element. Or it could be, remember, matter's all atoms, or those could be put together into molecules. It could be a substance that's pure, could just be one of those molecules and a lot of them and nothing else. And so we would call that a compound. So this would be something that was just one molecule, but lots of it. So like it's a pure sample of molecules. Maybe that's the way to say it. Well, an element's really going to be a pure sample of an atom. So that's kind of our kind of straightforward, you just have one thing. But most things are actually mixtures. And so that's our other category here. A mixture is going to combine two or more either atoms or molecules, or atoms and molecules for that matter. And so we've got kind of like two ways that we kind of classify these mixtures: homogeneous and heterogeneous. Huge words, right? Homogeneous just means that everything is uniform, that it looks the same, that if I was looking at, sorry, spelling that wrong. If I was looking at a mixture, I wouldn't be able to pick apart the different components visually or in any other way. It's all going to be mixed perfectly together. So the example here is an alloy, which is going to be a mixture of elements or atoms of two different types of like metals that are going to be evenly distributed amongst each other and create a metal that just looks like one thing. It's going to look like a pure substance, even though it's actually a mixture of substances. Another great example of a homogeneous mixture would be like salt water, right? Where you're looking at it like the glass of water doesn't look any different, but I know there's some salt in it because if I drink it, it tastes salty. Now, the other type is going to be its opposite. That's when you can actually see the difference between the components of the mixture. And we call that one heterogeneous. So here the example is solid gold in water, as if you're panning for gold. Another example would be like a vinaigrette, right? If I combine oil and vinegar, they're going to stay separated. I'll see the oil on the bottom and the vinegar on top. And it takes a lot of shaking to kind of mix them together. But even then, they don't stay mixed for very long. So it's a mixture, but one where you can easily see the different components. And so all of matter is going to easily fall into one of these categories. And this will become really important later when we start talking about how different molecules can form homogeneous mixtures or heterogeneous mixtures with what we call solvents. So other molecules like water or an oil or carbon dioxide. Um, and so we'll talk about solutions quite a bit in this class. And so those are going to be our homogeneous mixtures. And we'll be looking at immiscible compounds, and those will be our heterogeneous mixtures.